Okay, so here's the second part. So we're going to take a look at two numbers. We're going to look at 21 first. Now, is 21 prime or not prime?
21 is not prime.
Not prime. So we think it probably won't pass the test.
Yeah.
But some not prime numbers do pass the test. So let's just check. 1 to the 20th, what does that equal?
1.
It's 1.
1. What's the remainder when 1 is divided by 21?
It's just 1.
You know?
Mm-hmm.
What?
Yeah, 1 divided by 21 is 1. Remainder is 1.
Remainder is 1. Okay, now we have to calculate 2 to the 20th. And what is the remainder? The remainder when divided by 21. Okay?
Yep.
2 to the 20th is a big number.
Yeah.
Any idea what it is?
It's a little bit bigger than a million.
Why is that?
Because 2 to the 10th is a little bit bigger than 1,000.
Okay, so it's about 1,000 squared. So it's a big number. But there's a very interesting trick you learn in number theory that the remainders multiply. So I'm not going to go into that, what that means, because I'll show you what it means. But when we study number theory, we'll talk about that. So 2 to the 6th equals what? Anyone?
64.
64. What's the remainder when 64 is divided by 21?
Well, it's 1 because 63 is divisible by 21.
3, remainder 1. So this has a remainder of 1, and I just said remainders multiply. So 2 to the 6th times 2 to the 6th times 2 to the 6th has remainder 1 times 1 times 1.
Which is still 1.
When divided by 21. Now so this is a really helpful thing. So we don't have to multiply 64 times 64 times 64.
Yeah.
Because we know, or I've told you, that the remainders multiply. So what is 2 to the 6th times 2 to the 6th times 2 to the 6th?
2 to the 18th.
2 to the 18th. How'd you figure that out?
Because when you have numbers multiplying with powers, the powers just add.
The powers just add. So 2 to the 18th. Now what do I have to do to get to 2 to the 20th?
You have to add 2 squared to it, which is 4. I mean, no, multiply by 2 squared.
Times 2 squared. Now what's the remainder when 2 squared is divided by 21? Can you tell me?
It's 4.
It's 4, right?
Yeah.
Because 2 squared is just 4. So the remainder when 4 is divided by 21 is 4.
That means this doesn't pass.
So the remainder equals 1 times 4, which is 4. So 2 to the 20th has a remainder of, where did I write it? 2 to the 20th has a remainder of 4 when divided by 21. So that's pretty cool.
Yeah.
So we knew this wasn't prime, and it doesn't pass Fermat's little theorem anyway.
Yeah.
Okay, and 2 to the 20th told us that. And the neat thing is we were able to calculate the remainder when you divide by 21 without knowing what the number was. So that's one of the cool tricks from number theory.
Yeah.
That's how people from the 1700s and 1800s could do all these amazing calculations without calculators. That's not totally how, but one of the reasons how. Pretty neat, right?
Cool.
And then some other people figured out there were some numbers that pass Fermat's little theorem that are not prime. I'm going to show you one. So 1729, for example, passes Fermat's little theorem. People usually use FLT for Fermat's last theorem.
Yeah.
So I'll have to say Fermat's little theorem. But it isn't prime. It's 7 times 13 times 19, it turns out.
Cool.
I think, is that right? What's 3 times 9 is 27, 7 times 7 is 9, yeah, I think that's right. Okay.
Yeah.
And these are, the numbers, they have a name, a special name they're called Carmichael numbers. But 1729 I wanted to talk about because it's famous for another reason. Have you ever heard of this number before?
Well, I don't.
Have you?
No.
So there's a famous mathematician, Indian mathematician named Ramanujan. Have you ever heard of him before?
I don't think we've talked
Maybe
about it.
once.
He's one of the most famous number theorists around. In fact, some people think he might have been the greatest mathematician of all time. Unfortunately, he died when he was really young. that he was in the hospital and he got a visit from another great mathematician named Hardy. And Hardy came in a taxi cab, supposedly, and the taxi cab's number was 1729. And when Hardy got to the hospital, he said, "Oh, I came over here in cab number 1729. I guess that's not a really interesting number, is it?" And Ramanujan said, "No, it is really interesting." And he said, "It's the first positive integer that can be written as a sum of two cubes in two different ways."
Whoa.
What? Two cubes in two different ways. It turns out that this is 12 cubed plus 1 cubed, and it's also 10 cubed plus 9 cubed.
Cool.
Cool. Isn't that interesting? He figured that out in his lying down in his hospital bed.
Cool.
Do you see that? What's 10 cubed?
It's 1,000.
Do you know what 9 cubed is?
9 cubed. I think it's
What would you have to compute?
8. I think it's 81 times 9.
Yeah, 81 times 9. Do you know how to do that? 81
Yeah,
times 9?
that's 729.
1,000 plus 729.
Cool.
Pretty neat, right?
That means 12 cubed is 1,728.
Yeah, or 144 times 12. Yeah. So anyway, let's move on. The last video is going to be talking about Fermat's last theorem. Okay.
Alright.
Yeah.